Today's lesson is 12.7 on spherical geometry. The learning objective is, I can find distances on a sphere in area of spherical triangles. Example 1. Tell whether the following postulate in Euclidean geometry is also true in spherical geometry. Draw a diagram to support your answer. Parallel postulate: if there's a line and a point not on the line, then there's exactly one line through the point parallel to the given line. I don't know if you guys remember this from chapter 2, but if you have, let me make a drawing here. If you have a line made up of 2 points, right? And then one point that's not on the line, there's exactly one line that can go through that point that will be parallel to the given line. Parallel lines do not intersect. This sphere shows a line L, a great circle, and a point A not on L. Several lines are drawn through A. Each great circle containing A intersects L. So there can be no line parallel to L. So the parallel postulate is not true in spherical geometry. Euclidean geometry and spherical geometry, what is the difference? Well, on the left side, you can see Euclidean geometry deals with planes. So if you remember, plane is defined by 3 non-collinear points, where spherical geometry is defined on spheres, not planes. So sphere S contains great circle M. That's a plane that goes through the center of the sphere, and a point not on M. Great circle M is a line. On the bottom left, the vertices of triangle ABC are points in plane P, and the sides are segments. The sum of the interior angles of a triangle is 180 degrees, so we can use a measure of A plus B plus C equals 180. On a sphere, the vertices of triangle ABC are points on sphere S, and the sides are arcs of great circles. The sum of the interior angles of a spherical triangle is greater than 180 degrees. So this should say greater than, not equal. Okay, so a couple differences there, right? Finding distances on a sphere. Here's an example that's worked out. The diameter of the sphere is 15 inches, and the measure of arc AB is 60 degrees. Find the distances between points A and B. So really, that's just an arc length on the great circle. Find the lengths of the minor arc AB and the major arc ACB of the great circle shown. Let X be the arc length of AB, and let Y be the arc length of ACB. Okay, so first AB, if you guys remember that proportional formula that we learned in chapter 10, it's here on the left, arc length over total circumference equals the measure of the arc, or the central angle, over 360. Now the other arc, the major arc ACB, can be found using that same formula. And so the minor arc would be 7.85 inches, and the major arc would be 39.27. Okay, so looking at these examples on the right, we'll start with number 1. The measure of AB is 100 degrees. What are we trying to find here? Use the diagram in the given arc measure to find the distances between A and B. So it's X, arc length, over 2 pi r. So the diameter is 14, so r is 7. And we'll set that equal to 100 over 360. Then we cross multiply to solve for x. Dividing both sides by 360, we get x is about 12.22 feet. Number 2. So the measure of AB, arc AB, is 50 degrees, and our radius is half of 8, so that would be 4 millimeters. So x over 2 pi r would be 2 times pi times 4, and that's equal to 50 over 360. We'll cross multiply. And then divide both sides by 360. Which is approximately 3.49 millimeters. I just realized I did not find the major arc on number 1. Distances between point A and B. Yeah, I think we need to find the major arc too. So let's go back to number 1. So this is your minor arc. This is AB. So let's find ACB next. So again, we'll go x over, that would be 14 pi equals. So the whole circle would be 360, and subtracting the minor arc of 100, that would be 260. We'll cross multiply. Okay, and then we'll divide both sides by 360. And that's about 31.76 feet. Okay, let's find the major arc on number 2. So we've got x over 8 pi. Our minor arc was 50, so the major one will be 310. We'll cross multiply. And then divide both sides by 360. And that's about 21.64 millimeters. Here are a few more examples. If the measure of AB is 25, to find the minor arc, we'll go x over 2 pi r. So D is 20, so R is 10. We'll set that equal to 25 over 360. Dividing both sides by 360. We'll get approximately 4.36 centimeters. So that is for AB, the measure of AB. And then to find the major arc, let's see, 360 minus 25 will give us an arc measure of 335. And we get about 58.47 centimeters. Number 4, if the measure of arc AB is 125, we'll go x over pi times, 2 times pi times r, so r would be 20. And we'll set that equal to 125 over 360. And dividing both sides by 360, we'll get about 43.63 inches. That is for the measure of AB. And let's find the major arc. 360 minus 125 is 235. And that's about 82.03 inches. Finding the area of a spherical triangle. The area of triangle ABC on a sphere is, here's your formula, pi r squared divided by 180 times the quantity, the measure of angles ABC added together, minus 180. Where r is the radius of the sphere. There are some examples worked out on the right side. I'll let you read those on your own. The red steps out to the right are explained for you. So here's our triangle ABC. Let's look at number 5. So we'll first write our formula that helps us remember it and to substitute correctly. Okay, so the radius is 3. A plus B plus C. And then you just go to the calculator with that. You'll get about 21.21 square feet. A little bit different than area of a triangle on a Euclidean plane, isn't it? Okay, let's try number 6 up here. So pi times r squared, r is 9, so that's 81 over 180. And then let's see, what is 50 plus 90 plus 85 minus 180. Oops. That's about 45 once you do all that. So that will give you 63.62 square yards. All right, here's a few more examples. Triangle JKL. I'm just going to write it again. All right, the radius would be 12. Let's see, our angle measures are 138, 111, and 111. And that is an area of 452.39 square centimeters. Triangle MNP. The radius would be half of 15, so 7.5. And I'm just going to bring this parenthesis down here. So we would have 128 plus 48 plus 94 minus 180. And that's about 88.36 square inches. All right, take a minute to reflect. How are you feeling about spherical geometry? Are you able to find arc length in the area of a triangle on a sphere? Thank you for watching and for listening to this enrichment video. There will be some optional practice you can do as well. Have a great day.